So continuing with entropy and having already seen how we can predict entropy changes, we are now wanted to calculate entropy changes from exact values. And we can use the entropy change, we can use the entropy of individual compounds and elements to find the entropy changes in a particular reaction. So generally speaking, if what you can do is you can calculate the values of delta S, which is the change in entropy, from standard entropies, the entropies of individual elements. And the way simply it works is that the entropy change of a reaction is simply the sum of the entropy of all the products minus the sum of the entropy of all the reactants. It's pretty simple. It's literally the entropy of the products, what we achieved, minus what we started with. And I'll do some examples here to show you how we can use this, and it's pretty straightforward and simple. All you really need is the entropy of the standard entropies of the reactants and products in a question. So if I look at an example here, it says here calculate the entropy change for the following reaction. So the reaction happens to be 3 oxygens becoming 2 ozone molecules. And to find the entropy change for this reaction, we'll need to know the entropy of oxygen, given to us right here as 204.9 joules per Kelvin per mole, and the entropy of ozone also given to us. So what we really just need is to add them up to find delta S. So delta S for the reaction would be the sum of the entropies of the products minus the sum of the entropy of the reactants. Here the products are what? The products are just O3. So literally what's saying here, the 2 times the entropy of O3 minus 3 times the entropy of O2, because there are 3 molecules of O2 as the reactants and only 2 of ozone as the products. So here, and basically, so what is the reactants? The products are 2 times 237.7 minus the reactants, which is 3 times 204.9. And then you add them up and you get the answer. This comes out to minus 139.3 joules per Kelvin per mole. And by the way, this is a decrease in entropy. And you can only predict that because 3 moles of gas are making 2 moles of gas. So there's a decrease in entropy. And the delta S is exactly that. Let's take a look at another example, another question here. It says here, calculate the entropy change when 1 mole of graphite, which is C, is oxidized to carbon dioxide under standard conditions. So this is a reaction of basically the combustion of carbon or the formation of CO2. But they want the entropy change and not the enthalpy change. And the entropy change is basically the entropy of the products, basically, minus the entropy of the reactants. And the products are literally what? So what are the products? The products are just CO2. So it's this entropy of CO2 minus the reactants. The reactants in this case are the carbon, 1 mole of carbon and 1 mole of oxygen. And so the entropy of CO2 is given to us as 213.6 minus the other two. Carbon is 5.7, solid, so pretty low, and oxygen is 102.5. And here we can calculate the value this way. And that comes out to about 105.4 joules per Kelvin per mole. So this is the positive value, entropy increased here. And obviously, as you get more and more reactants and products, the calculation becomes a little more complicated. Let's do one more example. So here it says calculate the standard entropy change for the following reaction, the Haber's process, where they've given you the entropies of nitrogen, hydrogen, and ammonia, and you got 1 nitrogen and 3 hydrogens and 2 ammonias. So here the entropy change would be basically the entropy of the products minus the entropy of the reactants. My formula becomes smaller and smaller. Entropy of the products are basically what? What are your products? The products are 2 moles of the ammonia, so 2 times the entropy of ammonia. And the reactants are 1 mole of nitrogen but 3 moles of hydrogen. So You got 2 moles of ammonia, which happen to be 2 times 193, and minus from 1 nitrogen, which is 192, and 3 hydrogens, that's 3 times 131. And this would result in a negative value. Yeah, it gives you the minus 199 joules per Kelvin per mole. Joules per Kelvin per mole. So one of the things that they'll ask you in the exams is to find the delta S of reactions. One example more, and this is involving the aqueous ions that we had talked about earlier. If you remember, this was sodium chloride dissolving in water, and that was an endothermic reaction. But now let's find its entropy change. And the entropy changes will be given for the individual compound and the individual ions. So now the right hand side is not one product but 2 individual ions. And so the entropy change here would be the entropy of the products minus the entropy of the reactants. Products are basically the entropy of Na plus the entropy of chloride ions. And the reactant is simply the entropy of NaCl. Nothing is double molar or multiples, so you don't have to multiply anything here. So now what do we do? So the entropy of sodium ion is 321 positive, chloride ion is 56.5, while NaCl is only 72.1. And this math comes out to be positive 305.4 joules per Kelvin per mole. It must seem pretty straightforward to you now, having to calculate this. It's just simply products minus reactants.